Welcome back again. This is CCNP 2.0 switch and I am Aditya. In this section we are going to take a look about configuring and verifying Ethernet channel, how LACP or PAgP negotiation protocol work in their mode, either how we can configure manually Ethernet channel at layer 2 or layer 3 in load balancing. And we also going to take a look about Ethernet channel misconfiguration guard. So this is the scenario, this is the topic that we are going to cover in this section. So first we need to understand what is Ethernet channel. Hopefully you have gone through from the CCNA in CCNA 2.0. We have already discussed about Ethernet channel. So Ethernet channel is actually the technique which combine multiple physical links to work as a single logical link. Why so? Because if we are looking for load balancing, either load sharing or fault tolerant link, in such case we can use Ethernet channel. Ethernet channel somehow also known as port channel, channeling, link aggregation. In Windows, this is known as NIC teaming. So link aggregation, actually this is, if we say this is also means, generally it's known as link aggregation because you have several links and you want to combine into single logical link. So that's why known as the link aggregation. But if you're talking about Ethernet channel, that is vendor specification name, vendor specified name, NIC teaming, also vendor specified name. But we can say this is the link aggregation way. So where we can perform link aggregation? Link aggregation we can perform when we connecting switch to server, switch to switch, either router to router. In these three modes or in this three way or devices while we need to connect, we can perform link aggregation. But now we also need to understand why we require link aggregation while we going to connect with server. So suppose this is the server and server may be connected to a switch like this way, and server may have a multiple network interface card. You can combine that feature known as in Windows NIC teaming. So make sure if you enable NIC teaming in server or Windows box, that going to support with the switch. Almost the devices support if you're talking about switch. Same thing we can perform in switches as we can see right there, as well as router. So this is how you can put multiple cable or a physical link and treat as a single virtual link. So this is efficient while we using while we using spanning tree protocol. In spanning tree protocol, if this is working, if this work normal, only one port going to up and rest of port going to down. That may not convenient a network where thousands of hosts connected to the switch. So this is become a bottleneck. So maybe you're running 100 Mbps out of every interface, but what about your trunk or a backbone network or a core network? You only running 100 Mbps. You can combine these interfaces and make a single logical link. And how many number of link you going to add, that going to directly proportional to your bandwidth. So this is why we require Ethernet channeling. This can be also pronounced as gigabit channel, ether channel, depends. So the goal and objective of link aggregation, we can increase the bandwidth. Linear incremental bandwidth means whenever we add any link, that going to directly add your throughputs or increase your throughputs. Increase availability, if one of link going down, doesn't matter, rest of link going to work or behave like same way. Load sharing. So if we have a multiple path using link aggregation, they are not going to block by the spanning tree protocol. They will share their loads across multiple link or how many link are configured. Depends on the platform or switch model number. Auto configuration means you can configure, we'll discuss shortly. Rapid convergence, cheaper solution. Obviously, if you have existing switch and you may not able to purchase, somehow you may not able to purchase a higher bandwidth switch that has 10 gig or some other interfaces, you can use on existing switches. We can perform on layer 2 as well as layer 3. So in layer 3 we can perform routing. Free from operation mode. So once you created a trunk port, you can make, sorry, once you created a Ethernet channel, you can use this as a trunk, access or tunnel. So as per your requirement, you can configure. So I hope these things we have already discussed in CCNA. So I don't need to go through every line, each line. But yes, we need to just enforce the concept or recall the concept. So there is three ways to perform link aggregation. On, and there is two protocols that they negotiate. PAgP, that is Cisco proprietary, and LACP. So if you're talking about on, there is no kind of negotiation. What I mean by negotiation, let me explain a little bit. If we have a switch, we have a two switch connected back to back, might be couples of link, and if we running on right there on these links, we also need to put these interface on mode. So manual configuration required and misconfiguration suspectable. This is the problem. Actually, let me explain a little bit. If we applied one side on and somehow we taken delay or we forget to enable on another end as a on, it going to create a layer 2 loop, because in this side this is treated as a single link and this switch going to send BPDU out of every interface, means this one as well as this one, because they are working standalone. So that may create a cause, that may create a problem. So better for you, first turn off the member port, then after combine them inside a channel and then turn it on. PAgP, that's I told you earlier, the proprietary solution, port aggregation protocol by Cisco. This is means if you're talking about on PAgP and LACP, they are not interoperable. So if you're using one inside, means this is suppose switch 1, this is suppose switch 2. If you turn on mode on switch 1 and you're looking for PAgP on switch 2, that's not going to work. Same with LACP. So misconfiguration resolution, if we're talking about PAgP and LACP, if there is kind of misconfiguration, they are going to make it correct. We'll will demonstrate you means after some time. So LACP is a standard protocol, IEEE defined protocol. Any vendor can use it, and it has two modes, active as well as passive. Where we're talking about PAgP or Cisco proprietary protocol, it has auto and desirable. So this is the way, this is the three way that we can perform link aggregation. On both side or manual, we can say there is no kind of negotiation. PAgP or LACP. This thing we will means going to perform in this section, the practical configuration and all those things. So as I have already told you, PAgP, LACP and on, they are not interoperable or not compatible to each other. So on mode need to be defined both switches and is misconfiguration can occur. Yeah, obviously as I told you earlier. So let's see, we can use the negotiation to prevent misconfiguration and fast convergence. So for misconfiguration and fast convergence, we can use PAgP or LACP. What thing that we require? First, we need to understand little bit more. If you're talking about Ethernet channel, there is two things or two components going to involve. One is actually the port channel or Ethernet channel or a logical link, and second is the members. Members mean the physical link that going to combine inside a logical link. So if we want to form a Ethernet channel or a port channel or a link aggregation, we supposed to have identical settings out of all interfaces. Their port mode, their access VLAN, their trunk if they are operating as a trunk, allowed VLAN, their speed and all those settings. So if, let me take an example, if a switch running we may have a two link, one is running on 100 Mbps and second is running on 10 Mbps. They cannot become the member of port channel, or they are not actually agree to form Ethernet channel because their settings are not identical. They're supposed to be almost the same. So this thing we need to care. While we're going to form Ethernet channel, we're going to create or configure Ethernet channel or performing link aggregation. Make sure the switch ports settings are identical. So better for you, put your interface in default configuration mode. So interface default or default interface, you can use the command. There is some other things if you're talking about Cisco Nexus switches. There is some other things going to support like MTU and things are like unicast, multicast, broadcast tone control setting, priority flow control and untagged uh, QoS. So that's good. When the interface join Ethernet channel, the following individual parameters are replaced with the value of Ethernet channel. So let's discuss this line. Suppose again we're going to take a example of switches, two switches. Suppose we have a 3 or a 4 link. This is switch 1, this is switch 2. If we form a Ethernet channel, we created Ethernet channel, and whatever setting that we going to apply that Ethernet channel, that means going to apply all. I mean to say that if individually one link working on 100 Mbps, so the total throughput will be 400 or 400 Mbps. That means ether channel speed is 400 Mbps. So there will be the single MAC address going to use spanning protocol as well. So you don't need to bother, you don't need to care. Means spanning not going to turn off rest of port and will turn on only single port. That going to combine means all port going to forwarding state. In rest of setting that going to inherit from the port channel. So your member link going to inherit these settings. So that's very good. The following interface parameter remain unaffected when interface join Ethernet channel. If you provide any kind of description, that is not going to part of Ethernet channel description. CDP, LACP port priority in debounce as well. So first we need to understand what exactly happened when we use Ethernet channel or link aggregation. Actually, let me go through the example. This is the switch, and this is another switch, and there may be a server. Suppose server may also have a connectivity more than two or more than one link, I should say. This is switch 1, this is switch 2. So sometimes this is difficult to understand. People think that if, let's see, this is 300 Mbps, this is also 300 Mbps. If you're going to might be downloading some file from the server, you are not getting a dedicated 300 Mbps of speed. Maybe even you have a gigabit link. You know why? Because your load balancing perform on flow basis. That means if we have a same source IP address, same source port address, and same destination IP address and destination source port address, your switch going to treat as a single link and going to assign one of interface for you, not all. That means if another computer going to download some file or maybe going to talk to the server, your switch going to allot another interface because this is different flow that we originated from this computer. Similarly with this computer. So don't think if we have a multiple link, they are going to aggregate the speed to particular flow or individual flow. So in individual flow, your port or your switch may assign an individual link. So that is how your load balancing work. How we can perform load balancing? Destination MAC address, source and destination MAC address, destination IP address, source and destination IP address, and their port addresses as well. And make sure these are actually dependent on your platform or your model of switch. Maybe some of switch not perform all those things, but some of. So what are the valid mode for both switches to form Ethernet channel? Suppose we have a two switch and we want to form Ethernet channel. So what kind of setting or what setting is appropriate or valid on both ends so that they can form ether channel? So as I told you earlier or I mentioned earlier, on LACP or a PAgP, they are not compatible, they are not interoperable. That means we have to have used a single protocol on switch 1 and same protocol on switch 2. So if we put a switch on mode, another switch is on mode, so we're going to form link aggregation. If we're using PAgP and switch A, suppose that, let me clear this off a little bit. This is switch A, this is switch B, and this is the result. Switch A on, switch B on, they're going to form lag. Switch A desirable, switch B desirable, going to form lag or link aggregation. Desirable auto, again link aggregation. Active, this is LACP protocol, same. The result is active, passive, same. We cannot operate, means one switch has on and another switch have might be PAgP or LACP. They are not going to work because they are not interoperable. So better for us if we will go through the configuration and verification. So I'm going to pause my recording and going to turn on my devices, and then we'll go through step by step how we can configure, how we can verify, and all those things. This is the topology that we're going to work with. We have a switch 1, switch 2 connected with gig 0/0, gig 0/2. So first let's verify that because of spanning tree protocol, one of link are not forwarding data. So this is what the normal way. If we not combine or bundling this port, or we are not enable without enabling any Ethernet channel or link aggregation, your spanning tree going to block one of link. So let's verify first. Let me execute command do show spanning tree. On switch 2 we can see switch 2 is a root bridge. Since switch 2 is a root bridge, that not going to block any port. And switch 1 supposed to have block one port and one port as a forwarding. So this is how your spanning tree protocol work. It actually block an alternate port that may cause layer 2 loop. So what happen if we are going to create a port channel? It going to become a single logical link, and also your cost going to decrement or a decrease. So since both switches using the same cable or a same link, this is easy for me to use same command on switch 1 and switch 2. So this is what we are going to use. Let's see, we're going to use on, suppose. So how we can enable? Interface range, I'm going to select interface. So interface range gig 0 1 to 2, excuse me. First I would like to turn the off, and then after going to assign into the port channel. So channel, so CHENNEL group 1 mode on. This is what I'm going to use on both sides. So now we combine these two links work as a logically one link, not two individual. So the next task is no shut, so that they are not creating any kind of loop. Hopefully I have executed no shut on both link. Yes, exactly, they may take little bit time. And now we can verify do show spanning tree. We have a port channel 1 on switch 1, and this is the root port and forwarding. Cost is 3, and we can also verify on switch 2. Now let's see what happen if we configure one side of switch to work as a Ethernet channel or link aggregation, and somehow we forget to enable Ethernet channel on switch 2. That may cause problem. So let's see, make the default exit, and let's see, use the command default interface range gig 0 1 to 2. So copy and paste, excuse me. Paste. So now both port going to become as a default. There is no kind of configuration. Again your spanning tree protocol going to block one of port. So do show spanning tree. Let's verify exactly as we can see. So in this scenario, or now I'm going to use switch 1 working as on and no configuration on switch 2. Let's see what will happen. So on switch 1 there was interface, excuse me, interface range, yep, gig 0/1 to 2, and channel group, and I'm going to select group number 1. It actually depends on the platform how many group you can assign to particular switch. And then after I'm going to use mode, let's say on. So I created these two interface or combined these two interface for link aggregation on port channel 1 and turning it on to work as static link aggregation. But you know what? There may be cause problem as I discussed earlier, because switch 1 working as a single port right there. But switch 2 assume that there is two port going to upstream, sending BPDU out of this port as well as this port. But switch 1 will going to send only single port BPDU message. So that may cause layer 2 loop. Sometime your port may be going to pull on error disable mode because of your misconfiguration of Ethernet channel. So hopefully right now everything is fine. Let's see. Do so spanning tree. This is the port channel on forwarding. immediately we can see your port are going to pull in error disable mode, because as I told you earlier, they may create a layer 2 loop. So let's see if we execute the same command, do so spanning tree. There is no spanning tree instance running because port are turn off or error disable mode. How we can verify? Let me execute command do so interface status error. Excuse me. Status. It's supposed to be E. On switch 1 gig 0/1, gig 0/2 and port channel 1. That is the logical one. Two physical and one logical. These three port are going to error disable mode because of this is the reason channel misconfiguration. So spanning tree going to block this port. So that may create problem, that may create a cause. We need to take care when we going to assign particular port into Ethernet channel or link aggregation. Make sure the member ports are turned off and you have assigned both you assign or configure both on switches right configuration, then turn it on. So they may not going to create a cause if you performing on right way. So that's good. What happened if I told you earlier, if we are going to use PAgP or LACP? They are aware about this. They going to work as a single port, not they are not going to combine, since never not sending any kind of LACP or PAgP negotiation. I will use this port as a single even these port are combined. So better for us, we can go through the configuration and verification on switch 2. So let's see shut and let me exit out. Default interface range gig 0/1 to 2 on switch 1, because switch 1 is a switch that we have created already, Ethernet link aggregation, and I hope there is no port channel. So let me interface port channel. Is there port channel? Port channel or port 1? It was 1, so no interface port channel, making as a default one. Now what I'm going to create, what I'm going to do on switch 1, going to apply let's say PAgP. So that's good. First verify spanning tree is working or not. So spanning tree, excuse me. Yes, it is working. So interface range gig 0/122 channel group 1, and then after mode is let's say we have active, auto. If we are going to use active and passive, they are going to enable LACP protocol. If we're going to use auto or desirable, they're going to enable PAgP. So let's see, going to use PAgP or a PAG, not PAgP. For PAgP, I need to select auto or desirable. For instance, desirable. So I created these port desirable, means on switch 1, but I do not have configure anything on switch 2. So what going to happen? They supposed to work as an individual interface, so that they are not going to create any loop back. Sorry, layer 2 loop. So do so spanning tree first. Verify they are working as an individual. Let verify. Do so. Excuse me. Do so, and then after ether channel on switch 1. So ether channel. Excuse me. So ether channel, and let's see summary. You can see we have enabled PAgP, but gig 0/1 and gig 0/2, they are working individual or standalone. So this is the advantage if we are using PAgP or LACP. They are negotiate whether their neighbor is agree or not. If they find their neighbor is not agree to form Ethernet channel or link aggregation, they are going to use this port as a individual. So let me turn it on switch 2. Interface range, excuse me, gig 0/122 channel group 1. So channel group is actually locally significant, you can use anyone. Then mode desirable. So now they are going to work on right way, as I told you earlier. So better for you use LACP or PAgP. If you using on both end, make sure your member link are turned off before configuration on both end, and then after configuring, verify once again and then turn it on. So let's see whether we have a right way to working. Do so span tree. Yes, exactly, that we can see. So spanning tree and so port channel. Excuse me, let me execute on both switches. Do so ether channel summary. This is S and this is U. So U, that means capital U, that means in use, and S stand for layer 2 right there. So now they using PAgP protocol. So as I told you earlier, PAgP and LACP are not interoperable. So you can use one of these way to enable your interfaces in to configure your interfaces in for link aggregation. So that is good. Yes, we have already discussed in these topics, so I'm not going to do it again. You know what we left off? Load balancing and in layer 3. Okay, So since this is, let me verify, do so version, this is 2960 switch, that is not going to support or work like a layer 3. So I cannot create layer 3 link aggregation right there, but configuration is easy. You just need to execute command no switch port, but this switch is not going to support no switch port. If you are using the higher level switch or a layer 3 switch, they can work as a layer 3 link or a layer 3 link aggregation. And last thing that we need to verify, not last thing, we can enable Ethernet channel guard as well as load balancing. Let's see, first use load balancing. So ether channel, there's supposed to be a command. This is not ether channel, port channel. Okay, so port channel, and then after load balance, you can use destination IP address, destination MAC address, source IP address, source MAC address, and so on and so forth. But I'm not going to do this because this is the default configuration is better than if we change something. And now one last thing that I need to discuss, we can enable ether channel guard. So how we can enable ether channel guard? If we have a configure anything that is not proper way to configure, we can use spanning tree ether channel and guard. Ether channel guard? Oh, yeah, misconfiguration. So we need to enable on globally spanning tree ether channel guard misconfig. If there is misconfig enable, please go ahead and pull those port in error disable mode. Let's verify that we have enabled we have enabled spanning tree Ethernet channel guard misconfiguration. So spanning tree and then summary. Right there, that is enabled. Ether channel misconfig guard is now enabled. One more thing that I would like to mention, if we're going to configure any port channel, let's see first, let me keep all the setting default on switch 1 and switch 2. So interface range, gig 0/1 excuse me 122 gig 0122 this is supposed to be default interface gig 0/12 interface range. Let me select interface range gig 0/122 and copy that on switch 1, paste. So now they are working as a default behavior. So they are going to block by the spanning tree protocol. Do so spanning tree. Exactly that we can see. If we going to interface range gig 0/122 and then channel group, not channel group, first I'm looking for another protocol. We can use channel group, either channel protocol. So what is mean by channel protocol? Let's see, if we are using channel protocol, that means we are telling to switch, or we are configuring to switch, please use either LACP or PAgP. So we can change the mode, but we cannot change the protocol. What I mean to say, suppose we are going to use PAgP. Let me put PAgP right there. So I told on gig 0/122, please only use PAgP. So if we going to use channel group 1 mode LACP, let's see, for LACP using passive, they are not going to form the trunk. They are not trunk. They are not going to form the Ethernet channel, because you have already told to your port you need to operate in mode of PAgP. But if we are going to use desire, they are going to work. So once you created the port, now you can create it as a trunk, either access port. So that is very easy to configure. I'm not going to tell you, because you can just interface, switch port, mode, and then trunk. That is straightforward. There is some question that I have mentioned already. How many channel group can create? Actually, this is depend on platform. Does all switch platform, all method of load balancing support? Does all switches perform all method of load balancing? No. This is also depend on your platform. What kind of load balancing they going to perform? Does channel group number should be identical on both of end of switches? No, this is locally significant, as I told you earlier. So hopefully this is informative for you. Thanks for watching.